Dear students, again we will move on to the second part of this numerical session for the solution chapter. So I think in the first session we have solved nearly 6 numericals. Okay, so let's directly move on to the numerical number 7 from the solution chapter. Okay, calculate the boiling point of the solution which has 15 grams of magnesium sulfate dissolved in 550 grams of water. Assume I means it is called as Van der factor. Van der factor is equal to 2 for the solute. BP of pure water is 373.15 Kelvin, and then the molar mass of magnesium sulfate is given as 120 gram per mole, and also Kb, that is molar elevation constant, is also given. Okay, so let's have which is a solute and which is a solvent here. Let's have the solution for this. Solute is what and solvent is what? Which is the solute and which is the solvent? BP of the solution which has 15 grams of magnesium sulfate dissolved in 550 grams of water, means it is dissolved in water, means magnesium sulfate is a solute and water is a solvent. Water, we know that it is having a formula of H2O. Okay. Calculate the BP of the solution. BP of the solution means it is TB we have to find out. If it is TB not, means it is pure boiling point of pure water. So here it is only the TB, that is boiling point of the solution. It has how many grams? 15 grams of magnesium sulfate. Magnesium sulfate is a solute, therefore mass of magnesium sulfate is W2. It is equal to how many grams? 15 grams. It is dissolved in how many grams of water? 550 grams of water. What water is? A solvent. The solvent mass means W1 is equal to 550 in terms of which one? Grams. And already I factor is given. I means Van der factor is equal to 2. Already is given, because magnesium sulfate upon ionization gives magnesium 2 plus and SO4 2 minus. Therefore, how many particles are there? Totally 2 particles, and that number of total particles is given by Van der factor, that is equal to I. BP of the pure water is 373. Solvent means it is, water means a solvent. Solvent means it is a TB naught. What is that? 373.15 in terms of Kelvin. Molecular mass of magnesium sulfate. Molecular mass means M. Of solute magnesium sulfate means M2, it is equal to 120. And also the value of Kb is given as how much? Kb is equal to 0.52, I think, Kelvin kg per mole. So these are the things that has been given. First, the solute for this one is going to be the magnesium sulfate and the solvent is going to be the water. So here we have to find out the boiling point of the solution. Boiling point of the solution means a TB we have to find out. TB we have to find out here, and mass of magnesium sulfate taken is going to be how many grams? 15 grams, and it is dissolved in 550 grams of pure water. Therefore, W2 is equal to 15 grams and mass of the solvent, that is water, is equal to 550 grams. And also he has readily given that the I factor or the valence Van der factor for magnesium sulfate is going to be the what? 2. Then the boiling point of the pure water is already given. What is that boiling point of the water? Or it is given as TB naught is equal to 373.15 in terms of Kelvin. And also he has given the molar mass of magnesium sulfate is already given as 120, and the molar elevation constant Kb is given as 0.52 in terms of this one. Okay. We know that WKT means we know that delta TB is equal to I into 1000 kb W2 divided by delta TB into, M2 into W1. If I want to calculate the molecular mass, M2 is equal to what here? 1000 kb W2 divided by delta TB into W1. But here we want the boiling point of the solution first. Boiling point of the solution means first you have to know what is the elevation in boiling point. After that we can find out the value of this one. Okay, that is I into 1000 kb W2 divided by this one. That is equal to I is 2 here, I think, into 1000 into Kb is going to be 0.52 into W2 is what? 15 grams, so divided by Molecular mass is found to be 120 into W1 is how much? 550. That is equal to, if I simplify that, the delta TB becomes, delta TB is equal to, it is found to be 0.3466, 0.3466 in terms of Kelvin. Okay, that is elevation of boiling point. But this is actually what minus what? TB minus TB naught. TB minus TB naught. Therefore, what is TB here? TB naught plus 0.3466. What is TB naught already given? 373.15 plus 0.3466. That is equal to, if I add those two, it becomes 373.1534 means it is 4966 in terms of Kelvin. 15 plus 34 is equal to 49. Therefore, we are having 373.4966 in terms of which one? Kelvin. Means the boiling point of the pure water is found to be 373.15. By adding the solute called as magnesium sulfate to the pure water, the boiling point of the solution is increased to how much? 373.4966 in terms of which one? Kelvin. Okay. So this is about the numerical number 7 to calculate the boiling point of the solution along with the factor called as Vanta factor. Okay. So let's move on to the now the 8th one. Next we will move on to the numerical number 8. A 5% solution by mass. What is the meaning of by mass means? Mass percentage means it is mass of a solute in mass of the solution. Means both are expressed in mass, that is why it is called as by mass. Of cane sugar in water has a freezing point of 271 in terms of which one? Kelvin. Calculate the freezing point of the same 5% glucose in water if the freezing point of the pure water is going to be 273.15 in terms of which one? Kelvin. So here the freezing point of 5% solution of cane sugar is given as how much it is? 271 Kelvin. But he has asked to calculate the freezing point of 5% of, instead of sucrose solution or the cane sugar solution, we have to find out the which one? The glucose. That is if the freezing point of pure water is going to be 273.1. So here we have the two cases first. Case 1 and then the case 2. In the first case, first what is the meaning of 5% solution means? 5% solution of cane sugar. Cane sugar means it is C12H22O11. C12, cane sugar means it is called sucrose. 5% solution of cane sugar, that is C12H22O7 means, what is the meaning of this? 5 grams of C12H22O11 in 100 grams of the respective solution. In 100 grams of which one? Respective solution. Means, what is the freezing point of which one? The calculate the which point? Freezing point of that particular solution. That is delta TF we have to find out here in W 100 grams of the solvent here. 100 grams of the solvent. Okay. Now, in this case, W2 is equal to 5 grams and W1 is equal to 100 grams. 100 grams. Then, M2 is equal to, what is M2 here? Molecular mass of cane sugar. Cane sugar means it is C12H22O11. So, C12 means 12 12s are 144 plus hydrogen is 1, 122s are 22 plus oxygen is 16. 1611Z is going to be 176, I think. So on simplification, we are getting 342. What 342 is? It is the molecular mass of which one? Sucrose. Sucrose is also called as what sugar? Cane sugar. Okay. So directly I will mention that in the form of here TB naught is found to be the 273.15 in terms of Kelvin, and TB is equal to freezing point, I think, sorry, it is TF naught first. Here it is TF, freezing point of the solution. How much it is? 271 in terms of Kelvin. Therefore, what is delta TF? It is TF naught minus TF. TF naught is 273.15 in terms of Kelvin minus 271 means it is 2.15 in terms of Kelvin. Okay. Now, we know that what is the first formula? M2 is equal to 1000 times the K of W2 divided by delta TF into W1. I need KF first, because why I need the KF means KF is equal to M2 into delta TF into W1 divided by 1000 times the value of W2. So let's have the simplification first. What is M2 first? It is 342 in terms of the gram per mole, and delta TF is going to be 2.15 into W1 is going to be 100 divided by 1000 into what is W2 here? W2 is equal to 5. So upon simplification, the value of KF that I have found is the value of which one? The KF is going to be 14.706. 14.706. 14.706. Let us call this as case 1. Let us take the second one, case 2. Means by knowing the molecular mass along with the elevation, depression in freezing point, I calculate the value of which one? KF. Now KF is known because the solvent is same, but the thing is we have to find out the different, what is that? The freezing point of that particular sugar solution, if the freezing point of pure water is that much, that is 273.15. Okay. Now we will have in the second case, that is also 5% of glucose. Glucose means C6H12O6. C6H12O6 means W2 is equal to 5 grams and W1 is equal to 100 grams, and therefore M2 is equal to, what is M2 here? Molecular mass of solute. Solute is what? Glucose. Glucose is C6H12O6. 12 6 are 72 plus 1 12 are 12 plus oxygen is 16. 16 6 are 96. On simplification, I will get that as M2. Okay. So now, what is delta TF in the second case here? Delta TF is equal to 1000 times the delta TF is equal to 1000 times the KF into W2 divided by M2 into W1. That is equal to, what is delta TF? 1000 into what is KF that we have calculated right now? It is going to be 14.706 into what is W2 in the second case also? It is also 5 grams divided by what is the molecular mass? 180 in the second case for glucose, and W1 is going to be the 100 grams. That is equal to, if I simplify that, I will get the value of delta TF is 4.085 in terms of which one? Kelvin. But I need the freezing point of solution, glucose solution. Therefore, R from this, delta TF is nothing but what? TF naught minus TF is equal to, what's the value of that I calculated here? It is 4.0825 Kelvin. I need the value of TF is TF naught minus 4.085. TF naught is how much actually? TF naught is 273.15 minus 4.085. So upon simplification, I will get the TF value as, TF is going to be 269.065. 2065 in terms of Kelvin. 200 and, I will say another time. So 269.065 Kelvin is the which point? Freezing point of which solution? The glucose solution. He has given the freezing point of the solution is going to be 200 and how much? 71 Kelvin. He has asked to same calculate the 5% of glucose solution, and it is going to be 269.065. In the first case, I will calculate the value of which one? Kf, I think. That is a depression of freezing point constant. By knowing the depression of freezing point, we have calculated the freezing point of which solution? The 5% of which solution? The glucose solution. So this is one method, I think. We can have the another method with respect to this. Because in both the cases the solvent is same. What is the same here? Solvent is same. So first I can rub this. And in both the cases the solvent is also same. What is the solvent here? Solvent is water, I think. Okay. So on that basis let us have the direct formula to get the value of which one? So can rub this also first. This is one possibility. Let it be there itself, okay. Now, as solvent in both cases, that is 5% of cane sugar and 5% of glucose solution is same. Is what? Same. Kf is constant. Kf is constant. W2 is equal to 5 grams, that is also constant. W1 is also equal to 100 grams, that is also a constant. Okay? Then, from the equation, for two different solutes, from the two different solutes. So I will mention that as delta Tf into M2 of glucose is equal to delta Tf into M2 of sucrose. How I will get? I will just mention this one. We know that M2 is equal to how much Kf? 1000 Kf W2 divided by delta Tf into which one? W1. Okay? So 1000 is constant, Kf is constant, W2 is constant, W1 is constant. Why? In both the cases it is 5% means W2 is equal to 5 grams. And W1 is equal to how many grams? 100 grams. Therefore, as it is the same solvent means Kf is also constant. Therefore, all these terms. Therefore, M2 into delta Tf is equal to constant. M2 into delta Tf is equal to constant. Means for two different solutes, what are the two different solutions that I have chosen here? One is glucose, another is what? Sucrose. Means delta Tf into M2 of the glucose must be equal to delta Tf into M2 with respect to which one? Sucrose. Okay. So make this one very clear. That is, if which is the case, as a solvent is same, first Kf is always constant. As in both the cases, what is the percentage of the solution here? 5% of the solution. What's the meaning of 5% of the solution? Means 5 grams in 100 grams. Means W2 and W1 are same. So therefore, 1000 is constant, Kf is constant, W1 and W2 are found to be the constant are same. Therefore, what is equal to? M2 into delta Tf is equal to constant. M2 into delta Tf is equal to constant. By considering the two different solutes, what I can mention? Delta Tf into M2 of the first solute. Which is the first solute here? Glucose is equal to delta Tf into M2 with respect to sucrose. Okay. Now, what I need actually? What we need here? Delta Tf with respect to glucose is equal to delta Tf into M2 of which one? Sucrose divided by M2 of glucose. That's equal to. What is delta Tf in the first case? Delta Tf in the first case is 273. 273.15 minus 271. 273.15 minus 271. Into what is M2 of sucrose that I have mentioned? 342 is the which mass? Molecular mass divided by 180. So that is equal to, if I simplify that to delta Tf, so the delta Tf is found to be around 4.0 0.085 in terms of which one? Kelvin. What is this? The depression in freezing point with respect to glucose is going to be 4 point, this one. But this is, we know that it is TF naught minus TF. What is TF here? It is TF naught minus 4.085. What is TF naught? 273.15 minus 4.085. That is equal to, on simplification, I will get the same answer in the form of 269.0 in terms of which one? Kelvin. Okay. So this formula I have to be very familiar. When it is, if how much? For the two different solutes having a same solvent, first what is constant? Kf is constant. As in both the cases, this percentage of the solution, percentage of the concentration with respect to the solution in the same solvent is 5%, means W2 and W1 are found to be constant, or it may be the same. Therefore, by equating those two, cancelling 1000 K of W1, W2, I left with only the delta TF into molecular mass is always equal to constant. But for considering how many different solutes? Two different solutes, the delta TF into M2 with respect to the glucose is equal to delta TF into M2 with respect to the second solvent, that is solute, that is called as sucrose. Okay. So on substitution and simplification, I will get the freezing point of the 5% of the glucose solution is equal to 200 and how much? 69.065 in terms of which one? Kelvin. Okay. So that is about the numerical number, which one? 8th. Okay. Let's move on to the 9th now. Now, let's move on to the 9th now. Determine the osmotic pressure of a solution by dissolving 75 milligrams of which one? A non-electrolyte. 75 grams of a which electrolyte? Non-electrolyte. In 2 liters of which one? Water at 25 degrees Celsius, given the molar mass of the non-electrolyte is found to be 174 in terms of which one? Gram per mole. Okay. So here we have to find out pi. What is pi here? Osmotic pressure. Prepared by dissolving how much of electrolyte? Prepared by dissolving how much? 75 grams of electrolyte, 75 milligrams of a non-electrolyte, means electrolyte is a solute here. W2 is equal to 75 in terms of milligrams, that is equal to 75 into 10 to the power of minus 3 in terms of grams. Then it is dissolved or added in how much liters? Volume with respect to water is equal to 2 liters. How much liters it is? 2 liters. And the temperature that has been recorded is found to be 25 degrees Celsius, that is equal to 298 in terms of which one? Kelvin. Molar mass of the solute is already given as 174 in terms of what per what? Gram per mole. Okay. So what is the formula here? We know that as it is a non-electrolyte, means I is equal to 1. M2 is equal to, or pi is equal to W2 RT divided by M2 into V. This is a formula for the calculation of which pressure? Osmotic pressure for a non-electrolyte. Suppose if it is a electrolyte, means it becomes I into W2. I is a what factor? Vanta factor. What is I here? Sorry, W2 first. W2 is 75 into 10 to the power of minus 3 into R. As it is in liters, means the value of this one is going to be 0.0821 in terms of liter atmosphere per Kelvin per mole, and temperature that has been recorded is 25 degrees Celsius, that is equal to 298 in terms of Kelvin. Molecular mass is already given in the form of 174 into, what is the volume of that one? It is going to be the 2. Okay. Upon simplification, I will get the answer in the form of 5.2728. 5.2728 into 10 to the power of minus 3 in terms of atmosphere. Because if volume is in liters or dmq, okay, then R value is equal to 0.0821 liter atmosphere per Kelvin per mole. So this you have to remember first. If the volume has to be expressed in which one? The liters, then R value is equal to 0.0821 liter atmosphere per Kelvin per mole. Therefore, the pressure unit with respect to this one is going to be the what? In terms of atmosphere, and the value is going to be 5.2728 into 10 to the power of minus 3 in terms of which one? The atmospheres. Okay. Let's move on to the 10th now. Calculate the osmotic pressure of 5% mass by volume, solution of which one? Urea at 300 Kelvin. The value of R already given as 0.0821, and the molar mass of urea is going to be 60 gram per how much? 60 gram per mole. Means instead of mass and volume he has given as 5% solution of which solution? Urea solution, I think. First calculate the what pressure? Osmotic pressure, means pi we have to find out. 5% M by V urea solution means, which solution it is? Urea solution implies 5 grams of urea in 100 cm cube or ml of solution. How many grams? 5% of mass per volume solution means nothing but 5 grams of the urea dissolved in 100 ml or cm cube of solution. Means W2 is equal to 5 grams, V is equal to 100 ml. Okay, V is equal to 100 ml. And already the R is given as, what is that R value? 0.0821. What is that? Liter atmosphere per Kelvin per mole. And the molecular mass of urea, M2 is equal to how much it is? 60 gram per again, same, per mole. What's the formula? We know that WKT means it is, we know that. What is pi is equal to W2 RT divided by M2 into V. That's equal to, what is W2? 5. R value we have taken that has in the form of 0.0821 into temperature that has been given is, at what temperature? Temperature is given as 300 in terms of Kelvin. 300 divided by molecular mass is given as 60 into, what's the volume given? It is going to be the 100. Okay. So upon simplification, so I think 1s are 3s are, 3 1s are 3 20s I think. 3 1s are 3 20s are. 5 1s are 5 4s are. That is equal to 0.02 something I think. Here it is a 10th one I think. 10th is 0. So here, as we are expressing that in the form of liters means, here we have to make some correction, right? So here V is equal to 100 ml means, as it is 0.0821 in terms of liter means, it is given as 0.1 term in terms of liter, because 1 liter is 1000 ml. 1 liter is how much ml? 1000 ml. Therefore, it is just only 0.1. 0.1. So therefore, we can't cancel here like this. Therefore, the net result after simplification is going to be 20.525. 20.525 in terms of, as it is R is 0.081 liter atmosphere per Kelvin, means the unit of this osmotic pressure is also 20.525 in terms of which one? Atmosphere. That is the osmotic pressure with respect to how much percent of solution? 5% of solution. What that 5% of solution is nothing but it is mass per volume. What's the meaning of mass per volume? Means 5 grams of a solute, which is that solute here, it is the urea dissolved in how much cm cube of the solution? 100 ml or 100 cm cube of the solution. Based on that, I will get the value of W2 is equal to 5 grams and the volume of the solution is given as 100 ml. But as we are expressing that in the form of liter atmosphere, means volume has to be converted to which one? Liters. That is 1000 cm ml or cm cube is equal to 1 liter, means therefore 100 ml is equal to 0.1 in terms of liters. And the temperature is given as 300 Kelvin and the molar mass is given as 60 gram per mole. So we know the formula is pi is equal to W2 RT divided by what into what? M2 into V. Substitution and simplification gives the final result as 20.525 in terms of which one? Atmosphere. Okay. So that's about the numerical number 10th. Okay. So let's have the 11th now. Next, 11th, a 1.46 solution of a compound has an osmotic pressure of 783 in terms of millimeter of mercury. At 300 Kelvin, calculate the which mass, molecular mass of that compound, and already the R value is given as. Suppose if the pressure is expressed in terms of millimeter of mercury, the R value is taken as 62.36 in terms of liter millimeter of mercury per Kelvin per mole. Okay, so let's have first 1.46% solution of a compound implies, what's the meaning of that? 1.46 grams of a compound called as a solute in 100 cm³ or 100 ml. Liter means, or I will directly write that in the form of 100 ml of which one? Solution. That's the meaning first. 1.46% of that particular compound solution means 1.46 grams of a solute dissolved in how much ml? 100 ml of that particular solution. Therefore, W2 is equal to 1.46 grams and V is equal to 100 ml. That is equal to 0.1 in terms of liter. Why? Solute is 1.46 and the volume of that particular solution is going to be 100 ml. 100 ml means, as it is in liter millimeter, means it is expressed as 100 ml can be written as 0.1 in terms of liters. Okay. Then it is having an osmotic pressure. Pi is given as 783 in terms of millimeter of mercury at a temperature recorded of around, and we have to find the value of which one? M2 we have to find out. Molecular mass of the solute. We know that. What's the formula here? M2 is equal to W2RT divided by pi V. That is equal to, what is W2 here? 1.46 into what is R? 62.36 into what is temperature? 300 divided by what is pi? Osmotic pressure 783 into 783 into what is the volume here? It is going to be 0.1 in terms of liter. On simplification, the molecular mass is going to be the 11th 348.83 in terms of unit for this one is gram per mole. It is very similar to that of the previous one. There the molecular mass is given, we have calculated the osmotic pressure, but here the osmotic pressure is given but we have calculated the molecular mass. But the thing is, there we have expressed the osmotic pressure in terms of atmosphere. Okay, there the R value is going to be 0.0821, but here the pressure, osmotic pressure is expressed in millimeter of mercury. Therefore, we have to choose the value of R is going to be 62.36 in terms of liter millimeter per Kelvin per mole. Means, as it is in liter means, but it is given as 100 ml means 100 ml is equal to how many liters? 0.1 in terms of liters. Applying the same formula, but we have to get the molecular mass instead of osmotic pressure, because osmotic pressure is given, we have to calculate the value of which mass? Molecular mass. So that is about the numerical number, which one? The 11th. Okay, let's have the 12th here. Normal saline solution. Saline means it is actually sodium chloride, salt water. The major constituent of the sea water is actually the sodium chloride. How much percent it is? 0.9% by mass per volume. Sodium chloride solution. Calculate the osmotic pressure of a normal saline solution at 300 Kelvin. Given the molecular mass of NaCl is 58.3 and the R value is given as 0.083 liter bar per mole per Kelvin. So here 0.9% NaCl solution implies. What's the meaning of that? Saline means sodium chloride. How much percent it is? 0.9%. What's the meaning of that? 0.9 grams of NaCl in 100 cm cube or ml of the respective solution. Means I get the two factors here. What is that? W2 is equal to 0.92 grams and V is equal to 100 ml, but it is equal to 0.1 in terms of liters. For NaCl, ionizing as Na plus and Cl minus, I factor is equal to 2 here. We are having the high factor. Vanta factor is because it is an electrolyte. Electrolyte means usually undergo dissociation means greater than 1, association means less than 1. Okay. Now, I is equal to what? 2. And the temperature recorded is going to be 300 Kelvin. Then molecular mass of this one is going to be 58.5 in terms of gram per mole. And then the R value is already given. So what we need here? Calculate the, which one? Osmotic pressure. Why we have to find out. So first we know that what is the formula? Pi is equal to W2RT divided by M2 into V. It is a general formula first with a non-electrolyte nature. As NaCl is an electrolyte, just we have to have the another term that is called as I. I into what? W2RT divided by M2 into V. That is equal to, what is I here for NaCl? It is 2. What is W2? 0.9 grams. What is R? 0.083 into what is the temperature? 300 divided by what is M2? M2 is given as 58.5 into what is the volume of this one? It is 0.1 in terms of liter. Upon simplification, I will get the final answer as 7.6615. 7.6615. What is the unit here? R is 0.083 liter bar per mole per Kelvin. Means it is bar, not atmosphere here. If it is 0.0821 means it is atmosphere. If it is 0.083 means it is called as bar. Hence it is bar. Therefore, the osmotic pressure with respect to the normal saline solution. What is the normal saline solution? Saline solution is 0.9% of what Cl solution? NaCl solution. So means what is the meaning of that? 0.9 grams of a solute. What is that solute here? Sodium chloride in how much cm cube of the solution? 100 cm cube or 100 ml of the solution. Based on that, the solute mass NaCl is going to be W2 is equal to 0.9 grams and the solution volume is going to be the 100 ml. But as it is in liter bar per mole per Kelvin means instead of 100 ml we have to mention that in the form of 0.1 in terms of liters. Okay. Now, as we know that sodium chloride is the best example for an electrolyte, it ionizes to form which and which ions? Na plus and then Cl minus. Therefore, how many constituent individual particles in NaCl here? One Na plus and one Cl minus. Therefore, the Vanta factor I is equal to what? 2. And the temperature is already given as 300 Kelvin and the molecular mass of sodium chloride is given as 58.5 gram per mole. Then we have to calculate the what pressure? Osmotic pressure. We know that osmotic pressure is equal to what? Pi is equal to W2RT divided by M2 into V. It is a general formula with respect to which one? The non-electrolyte. Suppose if electrolyte comes, means just we have to multiply that by the Vanta factor that is going to be the I. Therefore, pi is equal to I into W2RT divided by M2 into V. So, substitute and get the answer. It is going to be the 7.6615 as it is 0.083 liter bar per mole per Kelvin means it is 7.6615 in terms of which one? Bar. Okay. So this is the completion of the 12th numerical with respect to the solution chapter. Okay. So the rest of the numericals that we will solve in the upcoming session or in the third session of this chapter. Okay. So thank you.